Hi there. Today we're going to be looking at writing the equations for parabolas, but we're going to look at it from the perspective of a parabola as a conic section, which simply means that we have a little bit more information to sift through as we find the pieces of the parabola to write the equation. All right? It's still the same thing that we've always done for writing the equations of parabola. We're going to take the simple route. We're going to find the vertex, we're going to find the a value, and then we're going to put this thing in vertex form. Okay, so to write the equation for parabola in vertex form, I only need the vertex and the a value. And remember, vertex form is y equals a times x minus h squared plus k. And what's going to end up happening here is we'll use this same format, but keep in mind that we might have a horizontal parabola now, so it adds a little bit of an element to this, where we'll write in the form x equals a times y minus k squared plus h. Okay, so all the x's and the y's will get switched, including the vertex itself, which was hk, now it's kh essentially, that we're looking for because they've been switched. All right. So if I look at the first one, and really the key to these is just going to be drawing a picture in order to figure out what this thing looks like. That'll tell us which direction it opens, that kind of stuff. All right, so for this one, it says write the equation if the vertex is negative 1, 2, and the directrix is y equals a negative 4. So I'm just going to draw a quick sketch of this thing. It doesn't have to be real accurate. But negative 1, 2 is going to be right here, so that's my vertex. And then it says the directrix is y equals negative 4. It's down here somewhere. So here's the directrix. Y equals the equation of a horizontal line. And so what that tells me, if my directrix is going this way, it means my axis of symmetry has to be going the other way. So here's my axis of symmetry, which that should tell me which direction this thing opens, because remember, the directrix is on the opposite side of this parabola as the focus, which means this parabola has to be opening up. All right? So now I've kind of identified what type of parabola this is. And then the other thing here, remember, the distance from the vertex to the directrix, that's our focal length, which this is equal to 1 over 4a. All right? And so what I have here, just by looking at this thing and counting the distance from the directrix to the focus, I can see that the distance between those things is 6, which means my focal length, the 1 over 4a, is going to equal 6. All right? And I'm doing that because, remember, the two things I need are the vertex, which I already have, and the only other thing I need is the a value. Well, this is going to allow me to solve for a. Okay? So if I scoot this guy over a little bit, let me bring this guy over. Maybe I'll bring these up. I'm just going to cross multiply, and I'm going to solve this for a. So here, that's like 6 over 1. I cross multiply. That's a 24a equals 1. I divide each side by 24. And I find out that a equals 1/24. And so since I know this is a vertical parabola, I'm back to the things that I'm used to here. This is going to be y equals 1 over 24 times x minus h, which is negative 1, so that becomes a plus 1 squared plus k, which is the 2. And that's it. All right, so I find the vertex, find the a value, plug it in. If I look at the next one, it says write the equation if the vertex is 2, negative 3, and the focus is 0, negative 3. Again, I'm just going to draw a quick sketch of this thing so I can get an idea of what it looks like. So let's see, 2, negative 3. It's going to be here. That's my vertex. The focus is 0, negative 3. So 0, negative 3 would be right here. Well, the focus has to be inside the parabola, which means my parabola has to open sideways like this so that it swallows up that focus. All right, and so then what I have here, again right here, the focal length, the distance from here to here, I can count that. It's 2 units. Well, that means that when I'm looking for these things, I need the vertex, which I already have, and I need the a value. Well, the a value, I can use that focal length. The focal length is 1 over 4a. So if 1 over 4a in this situation equals 2, now I just have to put that over 1, cross multiply, and solve. So I cross multiply, that gives me an 8a equals 1. I divide each side by the 8, and I find out that a equals 1/8. But now from here, it's a little bit tricky because this thing is sideways. Instead of being y equals, it's going to be x equals. I still have a here. And then in here, instead of x minus h, I'm going to have y minus the k value. That's plus 3 squared, and then plus h, which is 2. Again, every x changed places with every y traded places with every x. And that includes the vertex. So instead of having, the h inside, now it's the k that's inside the parentheses. All right, everything switched because it's the inverse. All right? If I look at the next one, it says write the equation if the focus is 1, 1, and the directrix is y equals a negative 1. This is probably the most difficult type of example that we can run into here. So again, I'm just going to draw a quick sketch. That line was not very well drawn. I'm going to try that again. Let me give myself a little bit more room this time. And I'm dragging my hand all over the place. Let me erase some of these stray marks. Okay, so I'm going to draw a quick sketch of this thing. I've got the focus at 1, 1. Which I'll draw like this. And then the other piece of information it gives me is the directrix at y equals negative 1. Well, y equals negative 1 is down here. That's a horizontal line. And so if I have a horizontal line here for my directrix, it means my axis of symmetry has to be perpendicular to that, has to go up and down. So I know that this is a parabola that opens up and down, but the issue is I don't see the vertex in terms of what I have graphed. I have to find the vertex this time, and it's all about the graph here. Remember, the vertex is the same distance to the focus as it is to the directrix, which means my vertex has to be exactly halfway in between these two. So on the graph, my vertex has to be right here in the center of these two things. And more specifically, it's got to be exactly at this point. Sorry, I meant to get rid of that. Let me try again. At this point right here. Okay, the vertex has to be halfway in between there. And so just by drawing the graph, I can see exactly where that vertex needs to be. It's the only point that's the same distance from the focus as it is from the directrix. And now from here, it looks like that's the ordered pair, let's see, 1, 0. And now I can also see that this parabola has to open up because it has to swallow up that focus, that focal point. And so now I know that it's going to be opening up, so I know I'm going to be doing the y equals. The only other thing I'm missing here is the a. And again, that comes from the focal length. I can see it right here. That's your focal length, and it looks like a unit of 1. Okay, so that means the 1 over 4a, which is my focal length, has to equal 1. And now from here, I put that over 1 and I cross multiply. That gives me 4a equals 1. I divide each side by 4, and I find out that a equals 1/4. And again, because this thing opens up, I know I'm going back to my standard, my vertex form of a vertical parabola. So it's y equals a, which is the 1/4, times x minus h, which is 1 squared, plus k, which is a 0, which means I don't need to write it. Okay? So again, when you approach these, you're still looking for the vertex and the a value. We just have more information to sift through in order to find that a value, in particular, the focal length. All right? So draw a picture, find out where your vertex and what your focal length has to be, determine the a value from there, and then plug it into the appropriate form, whether this thing is vertical or horizontal. Okay?